Hey class, Mr. Moyden here with another financial math example for our applied math class. This one deals with real estate, and it's a fairly complex calculation, so let's take a look. We have saved $15,000 for the down payment for a house. You have your eye on one that is selling for $210,500. Your bank has offered you a 30-year mortgage compounded quarterly at 5.3% interest. With other expenses, you have room in your budget for at most $1,500 a month for a mortgage payment. The question is, can you afford this house? So a lot to take in there. Let's try to figure out what formula we're going to use at some point or other. Based on this phrase here, quarterly compounded suggests that we're going to use the following formula. The compound interest formula, where n is 4. We're given a rate, so we have that. We're given a time, which is 30 years. And what we don't have is the principal, how much we're actually going to borrow. So let's think about that. If the house is selling for this amount, let's assume that our haggling would bring it down to that amount perhaps. That's how much we're actually going to sell or buy the house for. We have $15,000 in cash, or at least in materials to invest in, for our down payment, to spend rather. So let's go and find out how much we're going to borrow. So I'm going to subtract the down payment from the actual house amount. So the amount I'm actually going to borrow is this amount right here. I'm going to borrow the difference, right? $195,000 and $500. So $195,500. So that's going to be the borrowing amount. So we have the principal now. So let's go ahead and find how much I actually pay for that borrowing over this time period. So $195,500. 1 plus my rate is 0.053, compounded quarterly, raised to the compounding times the length in years, which in this case is a 30-year mortgage, which is a very common term for a mortgage. Notice there are no variables on this side, so I can actually type this in the calculator in one go. As usual, I'm going to be a bit careful. I'm going to type in that part first, and then deal with the rest. So let's see. We have 1 plus 0.053 divided by 4. Gives us that amount there. Raised to the 4 times 30 power, or 120 power. Gives us that amount there. So that entire calculation, including the exponent, is 4.8528 times the principal. So notice I didn't write the whole number down here. What I'm just going to do is going to multiply this previous amount times, answer times, 195,500. And the amount I pay, whoa, how about that? It's a pretty big amount. $948,724.80. Wow. For a house that costs $210,000. Now keep in mind, 30 years is a heck of a long time, so you can imagine with the amount of risk the bank is taking on and the length of term and inflation, this starts to become a little more reasonable. The question is, can we afford that? Well, if we can afford at most $1,500 a month, we need to figure out the monthly payment from this. So this is the total paid over 30 years, right? So let's figure out how many monthly payments that is. Well, there are 12 months in a year, so 30 times 12 is 360 payments. So that's 360 months worth of checks to send. Oops, not moths. Months. So let's divide this amount by the number of months in the term. So by 360, and let's see how much that's going to cost us per month. So there's the amount we pay divided by 360 months gives us the monthly payments, which is $2,635.35, which you can see far exceeds our budget. So compared to our budget, this is greater than $1,500, so the answer would be no. Now there's an alternate approach to this. What you could do instead is to multiply 1,500 times 360 to find the amount you can buy including interest, and compare that to this number, and what you'll find is 1,500 times 360 is significantly less than this number. So you cannot borrow enough to pay for this house, unfortunately. Alrighty, hope this helps.